Let's get right to the chase. I found my top 3 examples of me working through the ambiguous case with only one triangle. Yes, we have to watch out for no triangle as well as 2 triangles, but what I wanted to do was compile my best 3 examples of me showing you step by step how to find all the missing measures of your triangle when there's only one triangle for the ambiguous case. All 3 of these examples are inside of this video, and I hope you enjoy. So in this case, ladies and gentlemen, what we have is we have a triangle. Now, obviously, guys, you can see that B is like 150 degrees, right? So this doesn't really look like B would be 150 degrees. Well, that's OK, guys. You can have different oblique triangles. OK? You can have an obtuse oblique triangle. All I did was I just created and made it obtuse, right? But just remember, oblique, it is not going to have a right angle. This does not have a right angle. That's 150 degrees now. OK? But again, all we need to make sure when applying the law of sines is that we have a ratio with a side length and an angle, which in this case we do. We know that the side of B is 30 degrees over the sine of 150. Now, the only other information I have is C, right? So I can't do anything with A right now. I can only use C. So the only thing I know about C is its side length, which is 10. And I need to solve for the angle. So again, apply your cross multiplication. So you can say 30 sine of C equals 10 times sine of 150 degrees. Now again, we need to solve for C. Now remember, it's not when you have C, though, it's taking the sine of C. So you can't just like divide out a sine or something. That is a function. We can divide by 30. But now I have the sine of C equals 10 sine of 150 degrees over 30. To solve for C, this is a function. To solve for this, we have to now take the inverse of sine. OK? Yes?
Was it wrong for me to simplify 10 and 30?
No, you can simplify that. It's not going to be a problem. I just wrote it out. But yeah, you can definitely reduce that down. So now, all I can do is take sine of 150 divided by 3, right? Which is that simplified? So I can just take sine of 150 degrees divided by 3. Then I take the inverse sine of that. And that gives me 9.59. Again, for this chapter, we are going to be reducing down to the hundredths. So I'll say C equals 9.60. All right?
What if I cross out the sign and got 10?
Huh?
What if I cross out the sign and got 10?
Well, cross out the sign.
Or cross out the sign and I just do the inverse?
I don't know. I'd have to go and look at your answer. Any questions from here? Because we're not done. Mikhail, we're not done. Oh, OK. So now I know what C is, and that's a degree. So now I can say C is 9.60 degrees. That's 150 degrees. Now I'm going to ask you guys a question. This is going to be my precluding question. Is it possible to have more than one obtuse angle in a triangle?
Yeah. No.
Is it possible to have more than one 90-degree angle in a triangle?
No.
No. Remember that. OK? It's not possible to have more than one obtuse angle, right? So does this seem fitting that that's 150? I know that this can't be larger than 90 degrees, right? Or it can't even be 90 degrees, right? OK, just remember that, because we'll come back to that. So therefore, I have this. Now, is it possible for me to find this value? Yeah. It's really 180 degrees minus 150 minus 9.60 equals angle A, right? So then I'll just take 180 minus 150, which is 130, minus 9.60. And I get 20.4. OK, so now can we go ahead and solve for A? Because now I know this information. Can I now set up an equation for A to find the length of A? Yes. And now I can do law of sines on the other side. I already know what C is now. Now I can go and do this for A. So can I erase my C? Oh, I'll just do it over here. That's fine. So now I can apply cross multiplication over here. And I'll just make this very simple for you. Again, I'll try to do this very quickly. So A equals 30 times sine of 20.4 divided by the sine of 150. That's me applying cross multiplication for the A's, for this over here. OK, that's me doing that for A. So then to solve for this, I just plug it in my calculator. 30 times the sine of 20.4 divided by the sine of 150. And I get 20.91. OK? And does that make about sense? Does that feel like right for the triangle? Yeah, very good. So right now we have A equals 76, A equals 34, and B equals 21. The main important thing I know I can apply the law of sines is because I have a, Kevin, do you remember? How do I know I can use the law of sines with this? There's something that's really important that tells me that the law of sines would be my preferred method to use. Yes? Well, that's going to be an acute angle because it's less than 90. But there's something related with the side and the angle. The ratio. If you guys can remember, look for ratios of the same angle with its side. As long as you can create a ratio, right, then you know you can apply the law of sines. So I'll draw a picture because I like to kind of visualize what this will be. So I'll say that's 72 degrees, that's A, and then smaller case a will be 34. Smaller case, lowercase, that will be B. Oh, it's 76, you're right. Thank you. OK, so now by applying the law of sines, I can create my lovely ratio. So I can say, so remember the law of sines, A over sine of A equals, now I'm going to use the ratio with B, so I'll use B over sine of B. And it doesn't matter. I know sometimes I might have flipped them for you guys. It doesn't matter how you write your ratio, which one is above. It's just a comparison. So therefore, in this case, I have 34 over the sine of 76 degrees equals 21 over the sine of B. All right? So again, now to solve this, we have to go and apply cross multiplication, which I'm working on with my geometry students right now. So we go ahead and cross multiply. And then we solve for B. All right? I'm going to kind of make this a little bit quick. When I solve for B, if you have problems or you don't understand where I got to this point, please ask me, and I'll be more than happy to elaborate. OK, but when I solve, that's what I want to be getting at. All I did was I cross multiplied, set the products equal to each other, and then divided by 34 on each side. All right? I'm just trying to move it along, but please stop me if you want me to go through that. Everybody good? OK? Now, to solve for sine of B, we have to take the inverse. So B equals the sine inverse of 21 sine of 76 all over 34. You mean to solve for like B? Because sine is not multiplying by B. Right? Think about it this way. If I say the sine of 30 degrees, you're not multiplying sine times 30. Sine is a function, right? So what is the sine of 30 degrees? The sine of 30 degrees is equal to 1/2. We don't get that by multiplying 30 degrees by sine. We get that because taking the sine of 30 degrees, which we said represents the ratio of the angles of the triangle, equals 1/2. So we're not multiplying sine. This is the sine of 30 degrees. So just remember it's a function of the value. That's what sine, cosine, tangent, they're functions. So, and they're dealing with the ratio of your side lengths of a triangle. So when I have this, I need to use the inverse function. So then simply what I'll do is I'll just take 21 times the sine of 76, make sure I'm in degree form, divide it by 34, and then I'll take the inverse sine of my answer, and I get 36.81. Actually, 8.2. All right, now here's my question, though, that I have an issue with, that I told you guys. Oh, I didn't write this. In this class, sine of 30 degrees, right? I said that equals 1/2, correct? what about the sine of 150 degrees? The sine equals 1/2, right? Because sine is still positive. Cosine would be negative, right? So we have a problem. Because what if I say the inverse sine of 1/2? Well, we're only going to get 30 degrees. And again, I don't really have time because we didn't teach inverses in this course this year. So I don't really have time to say why they only give you the answer 30 degrees and not 150. But what I want you guys to understand is it's possible for us to have two angles. If I say, hey, here's my angle 1/2, what's the inverse sine of it? There's actually two possible angles, 30 and 150. And then what do you notice about the relationship between 30 and 150? What's just something that might, okay. The opposite on the unit circle, but what about their values, which is correct? What about their values when the number 180? Well, 30? Yeah, well, yeah, they're supplementary of each other. Yeah, they add up to 180. So what I want you guys to understand is, does this have another angle that has the same sine as this? Yeah. So how do we find that angle? Well, just like I can take 180 minus 30 to get 150, I can do that as well. So what I'll do is I'll say 180 minus 36.82. All right? 142, 143 point. Right? I'm assuming if I do all my math correct. OK. So what that means is theta could be 143.18. However, now, so here's what we didn't have time last class for because it was early release. This could be a possible angle, right? This could be our second angle. So it's possible, guys, when you're doing law of sines, that you have a case where there's two different triangles. However, is it possible for our angle to be 143 in this triangle? No. The reason being is because 143 plus 76 is over the 180, right? However, I'm going to tell you right now, there are cases where, let's say instead of 76, this is like 26. Then, is it possible for that to be an angle? Yeah. And is it possible for that to be an angle? Yes. So guess what? You have to solve both of them. So you'd have to do it twice. All right? But in this case, we luck out, and 76 is our angle. And therefore, this is going to make it over 180, so we don't need to worry about it. So we solve for b, which is now 36.82. All right, and now we just need to, so now we know 76 and, now we know a and b, so we can find c. So I just do 180 minus 76 minus 36.82. And I get 67.18. And I'll just write that out again. 180 minus 76 degrees minus 36.82 equals c, which is 67.18. Now, again, I can apply my ratios. So I'm going to use the same ratio over here. Now I'm just going to use c. So I do not know what c is, but I know what sine of c is, or sine of my angle c, which is 67.18. Again, I'll cross multiply. And in this case, we have c equals 34 times the sine of 67.18 divided by the sine of 76 degrees. So now I'll just take 34 times the sine of 67.18 and then divide that by the sine of 76. And I get 32.30. And there you go. All right. OK. So now what we're doing is we're given a problem that's we don't have the triangle. It's kind of like a lot what your homework was on. But what we're going to do is we're going to look at a single case solution. And what we notice is, first of all, let's just kind of draw a rough figure of what this triangle might look like. Where I could say, all right, here's A, which is going to be 42 degrees. All right. And then this length is going to be 22. And let's call B here 12. So therefore, that's going to be C, and that'll be C. Like I said, when you guys are creating your triangle, it's really just kind of up to you how you want to create it, because this doesn't necessarily have to be what this triangle could look like. This triangle could also, B could be an obtuse angle, right? We don't really know right now, but we're just going to draw a rough sketch to kind of get an idea of what the triangle will look like. But there's many different ways you guys can draw an oblique triangle. So the first thing that we notice is when dealing with something that has side-side angle is that we could have an ambiguous case. We talked about last class period when we were dealing with side-side angle and this is side-side angle. So whenever you have side-side angle, always think there's an opportunity now, Destiny, for you to have one answer, two answers, or no answer. All right, so this is what we call the ambiguous case. So let's go and take a look at this problem and see how it's going to work. So I have 12 and 22. So therefore, I can create my law of sines, which is going to be 22 over the sine of 42 degrees is equal to 12 over the sine of b. I don't need to be concerned about with the c because right now I don't have anything with c, right? All right, so let's go and solve for the sine of b. So we could say sine of b, obviously now I'm just going to kind of work through this a little bit quicker, is going to be 12 sine of 42 divided by 22, right? If you guys do all the kind of solving out there on your own. So therefore I have, let's see, 42 sine times 12, and then divide by 22. That's not right. Yeah, it is. Crap. So I have 42 sine times 12 divided by 22. All right, and then I get a decimal. So I have sine of b equals 0.36498 rounded. But remember, we want to find out what b is. It says the sine of b is equal to this decimal. So therefore, in sine b, we have to do b equals sine inverse of 0.36498. So when I do sine inverse, I get 21.4 degrees. Good question. So it says, remember the sine of an angle. The sine of an angle is equal to a decimal. That decimal is not going to make sense as far as that angle, right? Remember when we were talking about, when we even just did an angle, the sine of an angle is a ratio, right? The sine of an angle creates your ratio, opposite over hypotenuse, correct? So the ratio is equal to this decimal value. But we don't know what the angle is. So to find the angle, we have to take the inverse of sine of our ratio, and that's as a decimal, to find our angle. Because if you plug in the sine of 21.41, you'll get this decimal. Make sense? Yeah. Okay. So now we have this angle. But one thing you guys need to remember, when you're taking the inverse sine of something, Jacob. Whoa. So when you're taking the inverse sine, right, if you guys remember, sine, the inverse sine, we had to go between pi, negative pi halves and pi halves. So there's a possibility of having a couple different solutions when taking the inverse sine. So what we're going to do is we're going to subtract this from 180. So I'm going to do 180 minus 21.41. So we could also have b could also be another solution of 158.59. And what I want to kind of look at this is, let's kind of look at, actually let me look at your angle here. If you guys go back to kind of like the unit circle, right? Notice that if I was going to look at 21.4 degrees, that's that angle right there. The sine, your ratio equals 0.36948. So when you take the sine of that, that's equal to that ratio. But if you guys notice, if you use this as a reference angle, right, this would be 158.59. Those are going to have the same sine value, right? Because remember, it's y. If you go y over your r, your y over your radius. But if you notice, for these two angles, they have the exact same sine value, right? Because sine is positive. Do you guys notice that? 130? let me go through. Let's forget about decimals for a second. Let's just go through a regular unit circle. Let's do pi over 6 and 5 pi over 6. This point is square root of 3 over 2, comma, 1/2. This point is negative square root of 3 over 2, comma, 1/2. Do you guys understand in this unit circle that my sign value is exactly the same? Right? It's pi halves up, and this is 5 pi over 6. Notice what the reference angle is for this angle. The reference angle is pi over 6. These are exactly the same. Right, Caitlin? These two angles are exactly the same. And notice their y value is exactly the same. So when I'm looking at my sine, what I notice is I could have two different angles. I could have 21.4 or I could have 158.29 because my sine value for those two angles are going to be exactly the same. So when you have side-side angle, we have to make sure we look at this ambiguous case. We need to look at, all right, is the angle 21.4 or is it just going to be the angle of 150, or could we also use the angle of 159.59? Well, let's pretend this is 21.4, all right? But then let's take a look at what if B was larger? What if my triangle, so we know this is 42 degrees, but then it says it's 159 or 158.59, right? It's going to be an obtuse angle. Can we still create a triangle? Well, what I could do is say 42 plus 158.59. And if you guys notice, 42 plus 158, is that going to be above 180? So is it even possible to have a third angle? No. So therefore, this angle cannot create a triangle. Remember, this is dealing with when we have side-side angle. We have to look at both of our possible angles. Could it be this one or could it be this one? Well, in this case, it can't be this one because if I add this angle plus my other previous angle, I'm going to be above 180. So therefore, I'm just going to stick with 21.4. So I know 21.4 is going to be my one case. All right. Then let's just figure out what the rest of the triangle is. So if this is 21.4, I can do 180 minus 21.41. And then minus 42. And that's going to give me 116 degrees, 0.59. Now I can finalize my law of sines by doing 22 over the sine of 42 is equal to C over the sine of 116.59. And then again, we'll solve. So we could say C equals 22 times sine of 116.59 divided by the sine of 42 degrees. So now what we'll do is we'll plug that in. So 116.59 sine times 22 19.673 divided by 42 sine. And I'm getting C is going to equal 29.40. I don't really like working with this calculator, but you can see C equals 29.40. And then looking at this, does it look like this kind of follows along with this triangle? And do the lengths kind of seem right? This isn't like in the thousands or some decimal point, right? This seems like that we've created a correct triangle. Yes?
Okay, so you're saying that there's two solutions to C, basically?
There's a possibility.
So which one do you end up solving for in like easy?
That's what I went back to. Let me go. This is just the one case solution. Let me go and re-explain it again when I go into the no solution and the two case solution. All right. So I'll re-explain the whole process again when I get to our example. All right.